we have discussed about the equation I plus E is equal to A plus delta for the prism. Okay, I plus E is equal to A plus delta. That is the relationship between angle of incidence, angle of emergence, angle of prism, and angle of deviation. Now, if angle of incidence is changed, then angle of deviation simultaneously will also change, and for different angle of incidence, we get different angle of deviation, and the graph of angle of incidence and angle of deviation are taken into consideration. Then the graph of delta versus I is like this. Okay, this kind of curve you are getting. So what does this graph indicate? Initially, if the angle of incidence is increased, then angle of deviation decreases, and for a particular value of angle of incidence, this angle of deviation becomes minimum. Okay, at that time it is found that angle of incidence and angle of emergence both are same. So when delta becomes delta minimum, try to understand, when delta becomes minimum, at that time I and E are found to be equal. Okay, or in other term we can say when I and E are same, then delta is minimum. So that is shown here in this figure. At this point, delta has become minimum. At that time, we have experimentally obtained that I is equal to E. That is all experimentally obtained observation. Now further, if I is then increased, then delta increases. So what happens? Initially, if I is increased, delta decreases, becomes minimum. At that time, I is found to be equal to E, that is angle of incidence is equal to angle of emergence, and then further if I is increased, then delta also increases. This is the graph, and from this graph the theory is explained and formula for the refractive index is obtained. So that is given here. When I is equal to E, at that time delta becomes minimum, and that is called minimum angle of deviation or angle of minimum deviation. Now we have this equation for the prism I plus E is equal to A plus delta. Now I and E both are same, then we can say that instead of E, we can write I in this equation, and instead of delta we can write delta M. So this equation will take this kind of format. It becomes I plus I is equal to A plus delta M. So it becomes 2I is equal to A plus delta M, and therefore I will be equal to A plus delta M upon 2. Okay. Now we have this figure, okay, that is for the refraction by the prism. Last time we have discussed this. Okay. Now for this AB surface, try to understand this AB surface. At that surface we apply the Snell's law. Here the refractive index of this medium is N1, refractive index of the medium of prism is N2, and at this point Q we are applying Snell's law, and it becomes N1 sin I is equal to N2. Here the angle of refraction is R1, so N2 sin R1 it becomes. Okay. So this law is applied. N1 sin I is equal to N2 sin R1. Okay. And we have this 3 and 4th equation, 3rd and 4th equation we are having. This is your 3rd equation, N1 sin I is equal to N2 sin R1. Okay. So fourth equation we can write, because I is equal to E, try to understand. We have the condition that when delta is delta M, and instead of I we can write E. Okay, so equation can be written as N1 sine E. Okay, here the other face N1 sine E is equal to N2 sine R2. Okay, because at this point, means at point R, that is at this particular face AC, we can apply the Snell's law. Here you see this is the way the path of the ray is shown. This is the perpendicular. So if you apply the Snell's law, then here this becomes N2 sine R2 is equal to N1 sine E, that is angle of emergence we have to take into consideration. Okay, so this is considered to be angle of incidence, then angle of refraction, that is E. Okay, for this particular phase. For this phase, the angle of incidence is R2 and angle of refraction is E. So we can apply Snell's law at this AC phase as N2 sine R1. Okay, rather we can write this way, N2 sine R2 is equal to N1 sine E. Okay, we can write this here at this particular phase. Okay, these two angles are considered, so it becomes N2 sine R2. Okay, the angle which is made by the incident ray with this normal, you can see this is the normal drawn at a point of incidence, this becomes the incident ray, then it is making an angle how much? R2. So we can write N2 sine R2 is equal to, here this angle we have to consider, it becomes N1 sine E. Okay, so that equation is written here. Okay, N2 sine R2 is equal to N1 sine E. Okay, now I is equal to E, so we can write sine I is equal to sine E. Okay, so here instead of this E we can write I. So N1 sine I is equal to N2 sine R2. N2 sine R2. You can see N1 sine I is equal to N2 sine R2, and we have obtained N1 sine I. Okay, we have obtained also this same equation, N1 sine I is equal to N2 sine R1. So both the equations, they have their left hand side same, N1 sin I, here also it is N1 sin I, here RHS we have N2 sin R1, here N2 sin R2. So we can say N2 sin R1 is equal to N2 sin R2, or we can say sin R1 is equal to sin R2, or we can say R1 is equal to R2. Okay, so N2 sin R1 is equal to N2 sin R2, or we can say R1 is equal to R2, and we take one new letter instead of both. R1 is equal to R2 is equal to R we are taking. Now we have R1 plus R2 is equal to A. So instead of R1 and R2 we write R. So R plus R is equal to A. So 2R is equal to A. So R is equal to A by 2. Now we have the result. This N1 sin I is equal to N2 sin R. This is the result. Instead of R1 we have written R. Okay. So N1 sin I is equal to N2 sin A by 2. Instead of R we have written A by 2. And I, we have also obtained I is equal to A plus delta M upon 2. So in this equation, instead of I, it is written as a plus delta m by 2. So this equation number 6 takes this form, n1 sin a plus delta m by 2, n2 sin a by 2. Okay, so now if you take n2 upon n1, that is refractive index of medium 2 with respect to medium 1, that becomes sin a plus delta m by 2 upon sin a by 2. If n1 is 1, that is on both the side of prism there is a medium of air, then n1 will be equal to 1. So we can say n2, that is refractive index of prism, let us say this is n, instead of n2 we write n, then this equation will give you the refractive index of the medium of prism, that is n is equal to sin a plus delta m by 2 upon sin a by 2. Okay, this equation shows that for given prism, value of delta m depends on the angle of prism and the refractive index of the material of the prism and the medium in which the prism is kept. Okay, remember here, when delta is minimum, ray QR passing through the prism travels parallel to the base BC of the prism, and that is why this ray is shown parallel. This refracted ray is shown parallel. This refracted ray is shown parallel to the base BC. When does this refracted ray become parallel? When the delta becomes delta m. Okay. Now for the thin prism, derive dm, that is delta m or dm is equal to n a into n to 1 minus 1. Okay. Now when can we say that it is a thin prism? Okay. When thin prism is there, then the angle is very small, that is prism angle is very, very small. The prism which has small prism angle is called the thin prism. Now we have this formula of refractive index, n is equal to sin a plus delta m by 2 upon sin a by 2. If a and delta m is very, very small, a and delta m both are small, then sin theta is equivalent to theta in radian. Okay, so we can say sin a plus delta m by 2 is equal to a plus delta m by 2 in radian, and sin a by 2 is equal to a by 2 in radian. So this refractive index n can be written as n is equal to a plus delta m by 2 divided by a by 2. So this will be cancelled out. Okay, so you will have n is equal to a plus delta m upon a. Now just cross multiply this a with n. So na is equal to a plus delta m. So delta m is equal to a plus, okay, we make delta m as a subject of formula. Okay, so it becomes na minus a is equal to delta m. So delta m is equal to, a is common, okay, it becomes n minus 1. Okay, instead of delta m, sometimes it is written as dm, okay, angle of minimum deviation. Okay, thank you very much. Here our chapter is ending. Okay, try to watch this theory 2-3 times and write everything in your text notebook rather. Okay, thank you very much.